Alright, we've talked already about the powers of I and the cycle that they go through, which is a very interesting thing, and we talked about it for the first 7 or so exponents of I, and that cycle will continue for every exponent of I. So I to the 8th will be equal to 1, I to the 9th will be equal to I to the 10th, I to the 11th, and so on. Since this cycle repeats every 4 exponents, that means that every exponent that's divisible by 4, for example 12, will be equal to 1, what I to the 4th is equal to. I to the 32nd, which is 4 times 8, it's divisible by 4, so that's equal to 1. I to the 5th is, if you divide that by 4, you get a remainder of 1. I to the 9th works the same way. I to the 17th. All of these will be equal to I because they have a remainder of 1 when you divide it by 4. So these all have a remainder of 1 when divided by 4. When we add on to that, we can add I to the 9th, I to the 13th, I to the 17th. These all have a remainder of 2 when divided by 4. And any exponent, if you divide it by 4 and get a remainder of 2, the I to that exponent will always equal -1. Same way with a remainder of 3. It will always be equal to -I. So a little example about what we're talking about here. I to the 134. We can simplify that easily if we take the exponent and divide it by 4, and we want to figure out what the remainder would be. So 4 can't go into 1. 4 can go into 13 3 times. 3 times 4 is 12. We'll subtract that, get 1, bring the 4 down. 4 can go into 14 3 times again. And then when we subtract that, we're left with 2. And 2 is our remainder. So I to the 134 is going to be equal to the same thing as having a remainder of 2, which would be -1. Another example, I to the 343. So if we take 4 and divide 343 by that, 4 can't go into 3, but it can go into 34 8 times. And then 8 times 4 is 32. When we subtract that, we'll get 2, bring down the 3. And then 4 can go into 23 5 times. That would be 20. So we have a remainder of 3 this time. So if we look back at our chart, anything that has a remainder of 3 is equal to -I.